Hi, this is Mrs. Rodriguez, your algebra teacher. This video is about lesson 9-7, all about special functions. Okay. All right. So far we've looked at sorry. Do that again. So far, we've looked at different types of functions. We've looked at linear functions, quadratic functions, and then also exponential functions. Okay. So for this lesson, we're going to look at a couple of special types of functions that may look a little bit different. Okay, than what you're used to seeing. Okay. So first type of function is called a step function. And if you notice, the reason they call it that, this is what a step function looks like. It kind of looks like a set of stairs. If you imagine somebody like walking, it looks like they're climbing up a set of stairs. Okay. And it's a series of line segments. Okay. Notice these are line segments, not a line. It's not a curve. It's not an asymptote or anything like that. Okay. It's a series of horizontal line segments. Okay. And because each part of a step function is linear, this type of function is called a piecewise linear function. Okay. One example of a step function is the greatest integer function, which is the one we're going to take a look at, where f of x is the greatest integer not greater than x. So for example, if we're trying to find the value of 6.8, it would equal 6 because 6 is the greatest integer that is not greater than 6.8. So in order to be 7, it would have to be 7 point something. Okay. All right. So here it says to graph 2, and then this is the step function of x. Okay. Okay, sorry, there was no graph there, so I just had to add one real quick. All right, so what we're going to do is set up a table of values and then graph those values to get a better idea of what this graph is going to look like. Okay, so we're going to plug in a value for x, and then I'm just going to figure out what 2 times x would be, and then figure out the 2 of the function, the piecewise or the step function of x would be. Okay, so if I plug in 0 for x, well, 2 times 0 is 0. So then the step function times 2 would be 0. Okay, so I would have a point at 0, 0. Okay, and then I also need to know if I plug in 1 in for x, so that would be 2 times 1, which is 2. And then my value would be 2. So I know I would have a point at 1, positive 2, right? But I need to know what happens, because remember, these are horizontal lines. So I need to know what happens from here to here. So if I put in 2500ths, well, 2 times 2500ths is 0.5, right? And the closest integer would be to 5/10 would be 0. So in between, these values would also be 0, okay? And then since the value when I plug in 1 is 2, I would have an open circle here, and then I would have a horizontal line connecting the closed circle and the open circle, okay? If I plug in 1 and 2500ths, then 2 times 1 and 2500ths would be 2.5, and my closest whole integer without going over x would be 2. Okay, so again, I have this horizontal line, and I would have an open circle, because if I plug in positive 2, then this would be 4, and my closest integer is 4. Okay, so here I have positive 2, and then I would have a closed circle at 4, and then this pattern would continue. Okay, it's going up 2 like that. and I can even go down to like this. Okay. So that means, I believe it also asks for the domain and the range. So for the domain, remember that's your x values. We can continue this graph going towards the negative. We can continue this going up towards the positive. So the domain is going to be all real numbers. Okay. And then for the range, notice the range is only, it's not every single, it's not like, -1, 0, 1, 2, 3. It's going, these are the y values. It's going to be here at -2, 0, 2, 4, 6. So it's all even integers. Okay, all even integers. Okay. All right. And then another type of special function are, it's going to be an absolute value function. Okay. And these graphs are V-shaped, okay? Usually the domain is all real numbers and the range are all non-negative real numbers, because remember, you cannot take the absolute value of something and get a negative value, okay? So we want to be able to find this point, and then we can, we can find a couple values on each side of the vertex, and then we know it's going to be a V-shaped. So once we have at least 3 points, we can draw that graph, okay? So here it's asking you to graph f of x is equal to the absolute value of 2x plus 1. So remember, f of x cannot be negative, okay? So it has to be greater than 0, okay? So we're going to solve for 2x plus 1. So we would subtract 1 from both sides, so that would be -1. This would be 2x, divide by 2, and then we get -1/2 for x, okay? So x has to be, so basically our, sorry, this should be equals. I don't know why I was doing absolute value. Okay. So x has to be equal to -1/2. So that's going to be our vertex. So over on the x-axis, our vertex is at -1/2. Okay. So then I'm going to pick some values less than -1/2 and some values greater than -1/2. And then plot those points so I can see what my graph is going to look like. So let's say I plug in -3. Okay, so if I plug in -3 in for x, that would be -6 plus 1, which would be -5. And then I'm taking the absolute value of -5, so that would be +5. Okay, if I plug in -2, this would be -2 times 2, which is -4 plus 1 is -3. So the absolute value of that would be +3. I'm going to plug in 0 because 0 is greater than -1/2. So 2 times 0 is 0 plus 1 is 1, and the absolute value of 1 is +1. And then if I plug in, just do one more, plug in 2. 2 times 2 is going to be 4 plus 1 is 5, and the absolute value of 5 is 5. So I'm going to plot these points. So -3, 1, 2, 3, +5, 1, 2, 5, and then -2, +3, and then 0, 1, and 2, 5. So, oops, 2, 5 will look like this. So when I graph this, remember it's going to be a V shape. It's going to keep going. So my domain, my x values are going to keep getting greater and greater, my y values as well. So it's going to be all real numbers. And then remember, the range are the y values. Okay, I'm sorry, I think I misspoke. For the x values, they're going to keep getting greater, keep going up to the positive, and then they're going to keep going this direction for the negative. Okay. So for the range, my values, they're going to keep going up. They're all positive, okay, because my vertex is here at the x-axis. So everything has to be greater than 0, okay? Greater than 0. All right. And then another type of function is where you're going to be asked to graph something like this. You have 2x plus 1 if x is greater than 0, and then 3 if x is less than 0, okay? So let's first look at this one right here, where it says 3 if x is 0, okay? X is less than or equal to 0. So you might be thinking, okay, that's going to be a horizontal line at positive 3, right, on the y-axis, okay? Because remember, this is y equals 3, okay? So it's going to be a horizontal line, but it only wants it for x when it's greater than or equal to 0, okay? So when x is 0, here, we would put a circle here, and this is going to be a closed circle because it says greater than or equal to 0. And the reason I put it here because this is positive 3. And then it would be going this direction, okay? Because it's less than 0. So all the values of x where it's less than 0. I wouldn't go all the way across, okay? Because it's asking specifically for less than or equal to 0, okay? So then my other graph here, the 2x plus 1 if x is greater than 0. So here I have, I'm going to plug in some values, right, for x, and then find out what f of x is. So if I plug in 0, then that would be 2 times 0 plus 1 would be 1, right? So when x is 0, f of x is 1, okay? But it has to be greater than 0. So I'm going to have an open circle at positive 1, okay? Open circle at positive 1. So then what's going to happen when x is 1? Well, 2 times 1 is 2, plus 1 would be 3. And I'll just do a couple more of that, just do one more. When x is 2, 2 times 2 is 4, plus 1 would be 5, okay? So I can see that when x is 1, y is going to be 3. And when x is 2, y is going to be 5. And then this is going to be linear, right? So it's going to be going like this. It's going to keep going in that direction, okay? So if it also asks for the domain and the range, so for the domain, I can see that x values, they're going towards the negatives, and then over here, the x values are going towards the positives. So that would be all real numbers. And then for the range, I'm looking at my y values. Well, that would be when f of x is greater than 0, right? Because my lowest point is 0, but it's not equal to 0. So it has to be, my lowest point is positive 1, okay? But it's not equal to positive 1. So it has to be greater than 1. So that is my range, okay? All right, so just to summarize the different types of special functions, we have step function. Remember, it looks like stairs, okay? And then we have absolute value function, okay? Those are V-shaped. And then we have piecewise defined functions, okay? And we can have two linear functions going in different directions there, okay? So that's all. Hopefully this video was helpful to you to get a better understanding of these different types of special functions. If you're still a little bit confused or have a couple of questions, please call, text, or email me, or stop by my office hours and I'll be happy to help you. Okay? You have a great day.